Imagine you are standing in a room with 3 light switches. Down the hall, behind a closed door, is a second room containing 3 light bulbs. Each of the 3 switches in your room controls exactly one of the 3 light bulbs down the hall. You can manipulate these switches as many times as you like. However, you are only allowed to make a single trip to the room with the bulbs. Once you walk down that hall, you cannot return. Your task is to match every switch to its specific bulb. Guessing isn't an option. You need absolute logical certainty. Looking at this logic model, let's test the most obvious approach. Turn on a single switch, then walk down the hall. When you arrive, one bulb is brightly lit. You know exactly which switch controls it, but you're left with 2 dark bulbs and 2 switches left in the off position. There is no way to tell which goes to which. So you try the second logical option. You flip 2 switches on, leave one off, and head to the other room. Now, you easily identify the switch for the single dark bulb, but you are staring at 2 illuminated bulbs. It's impossible to determine which switch operates which bright bulb. If you'd like to solve this yourself, pause the video now, because if toggling switches on and off doesn't provide the answer, we are missing a variable. As long as we treat this as a pure math problem relying exclusively on binary on or off logic, the puzzle is mathematically impossible. On this blueprint, we see the cognitive trap we've fallen into, concept mode. Our brains are optimized to navigate a complex world by reducing objects to their primary intended function. We are failing because we are defining a light bulb strictly by its concept. We see it purely as a tool that provides light, meaning it is either illuminating or dark. To solve the puzzle, we have to shift into content mode. This requires looking past what a tool is supposed to do and examining its actual physical reality. When we examine the physical content of a traditional light bulb, we find the missing variable. Every bulb emits light, but it also generates physical heat when left on. Shifting your perspective from the conceptual purpose of an object to its physical properties reveals the data needed to solve difficult problems. Let's apply this to our control panel. Turn switch number 1 on and wait a few minutes to let that heat build up. Now, turn switch number 1 off and immediately turn switch number 2 on. Leave switch number 3 completely alone. Now take your 1 permitted trip down the hall to the bulb room. Only 1 bulb is lit. Because switch 2 is the only one currently in the on position, you can verify that it controls this bulb. When you touch the 2 remaining dark bulbs, you discover one of them is physically warm. You turn switch number 1 on and let it sit before turning it off, meaning it belongs to switch 1. This leaves 1 dark bulb that remains stone cold. By process of elimination, it belongs to switch number 3. When you encounter an unsolvable problem, investigate your assumptions. Shifting your perspective from concept to content reveals the variables required for a solution.